All right. Sorry for that, but I guess wasn't in our control, but half of the class is gone. That's all right. So yeah, this is an example of an Atari game. And the initial performance you see like it's pretty slow, and the agent learns how to kind of optimize its reward, and it keeps on going. And then like take a look at how quickly it learns from its environment. And after 30 minutes of training, it's super fast and it can do everything super optimal. Then another game from Atari, which was called Assault, similar case. They trained a reinforcement agent, and initially the agent was dying and learning, but then it kind of optimized itself and learned how to move forward. And then after half an hour, it learned like that. So a reinforcement learning is an agent which learns from its environment and optimizes its route and goes forward. Pac-Man is another example. This is also Pac-Man created using reinforcement learning. We don't have to watch the whole thing. But yeah. No. So in this example, the agent would be the Pac-Man itself. And what you have done is you have told this agent that every time it goes through, for example, so every time it eats this is a plus point. Every time it gets that point and eats the ghost, that's also a plus point. But if it's not eating those, or if it just goes and directly eats them, that's like a penalty for the agent. And when you associate these rules and then you run the simulation, then the algorithm will try to optimize its reward, collect as many points as possible. Now, this is a perfect example of this algorithm which worked well. But another instance where it cannot work well is also because when the agent can just try to assume, okay, I don't have to eat that specific dot over there, which was to eat the ghost. How about if I just eat on eating the points and ignore the ghost altogether? That's another alternative, which can also happen in a real world situation. This is the perfect example I'm showing you. But there are like 10 different instances of how this agent can react and maximize its reward. And every time and that's the predictability which we're not sure about, because this is not the result to come out every time. Every time you run it, a different result can come out. Because every time it would have learned, I need to increase my reward, and it will find a different way to go forward. Now, why am I showing you these games? Why am I showing you older games? And the reason why I show you these old games is because these are lightweight games. It's very easy to load them onto your computer, make a simulated environment, and just run an agent on it. You don't have to have a GPU. You don't have to have a very good PC to work with this. They have low graphics and low requirements to actually work with them. If you want to try reinforcement learning on your own, go to gym.openai.com. OpenAI already has a lot of those simulated environments. You can download them, try working, make your own agent, and test it out. It will be a very fun example for you to try out. Now, recommender systems are absolutely very important. I mean, everything is important, but they're also very important. The reason they are important is because we use them on a daily basis. So this is something like if you want to have a relevant suggestion coming up, a recommender system will give you a relevant suggestion. For example, you watch a show on Disney Plus, HBO, or blah, 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 Netflix. Once you are done watching the show, the next suggestions you're going to get were based on your previous watching history. That comes from recommender systems. That tries to find the patterns of the next thing you're going to see. Your Facebook feed, your TikTok feed, your all social media feed, that's based on recommender systems. These algorithms recommend what you will see next based on what you have already seen before. Another example would be if you go to a store and you're buying things, what I'm going to buy in the store is different from what you are going to buy from the store based on your interests and habits. We know personally, but then the algorithm learns it from our different patterns, like our buying techniques and our shopping interests and so forth. Some people call it a breach of privacy. I think this is an amazing thing. An algorithm who can predict what you want is okay. People call it a breach of privacy, and yeah, to an extent, it would be a breach of privacy. But isn't it amazing that you have an algorithm which can predict your next move, which can tell like what kind of shows I'll be interested in, what kind of things I'm going to buy, where would I go in the next half an hour? At one extreme, it's a huge breach of privacy. If someone knows where I'm going to go, but on the other extreme, if you look at a technological point of view, it's an amazing advancement that now an algorithm can predict your next move. So if you look at machine learning in an overall big picture, you have these branches of machine learning. You have supervised machine learning, unsupervised machine learning, reinforcement learning, recommender systems, and then we are going to focus on supervised and unsupervised, these two only, because these are the ones which we use most of the time in a practical way. And then next lectures, we're gonna talk about supervised classification regression and check like 2 or 3 different algorithms. And then unsupervised, we're gonna talk about clustering only, and then a few algorithms around that one. I think we'll have total 4 classes on machine learning. Then we'll be done with machine learning. And then we can talk about AI ethics, and we can talk about large language models. Then we'll be done with the class. Okay, the last slide. So when would you, if you are given a problem and you are like, okay, you have to figure out if you're gonna implement the problem using simple traditional programming, or you have to use machine learning to fix it. So you need to figure out when, and then you need to do an analysis. So the general rule of thumb is that if you look at a problem and you realize that you have certain data, which is very hard to process using normal computation, normal programming, like equations are complex, handwritten rules become too complex, like you cannot have thousands and thousands of rules, then perhaps you should use AI, because you don't have a rule-based system anymore. It's a pattern-based system. If you also see that the rules are constantly changing, sometimes you know exactly your business, the problem you're trying to fix, and then you specify some rules. But if you see like rules are always changing, you have to add in 5 rules today and 10 rules tomorrow and take away some rules, and it's becoming more complex to work with rules, then you have to realize that this is not a rule-based system anymore. It's a complex business which keeps on evolving. Then perhaps that's a business you could use some AI in. An example for that would be a fraud detection, because it's hard to detect fraud. You never have a specific, sometimes you have certain profiles which you define in a fraud, but most of the times people fall out of those profiles. Yeah. If you take a look at stock trading, sometimes it will seem very obvious that, okay, you can see on a overall picture the stock is going up or a stock is going down. But when you actually start trading, you realize you don't ever have control over the stock price. It keeps on fluctuating, and you don't understand the variables, what impacts the stock price. A very simple example. And if you want to be able to predict how the shopping trend would be on a specific day, or how it will impact like the holiday season or so on, these are kind of examples where the nature of the data itself keeps on changing. The stock price goes up, goes down. You don't know why it's going up, going down. You can't find a pattern because it's hard for you for us as humans to find a pattern. You want to find a shopping trend. Why are people buying more? Why are they buying less? You can't see it because it's too many variables involved, too much pattern involved. Then you have to think about using AI, because AI can find those patterns for you, which you won't be able to find. Yeah, that was it for today. I think we'll finish up. Thank you so much. I got a question if we'll have a class next week or not. In my schedule, it shows we will have a class. I will ask my boss anyway. If we are giving a week off, I will inform you within a day or two if we have a class next week or not. We'll have a lab tomorrow and day after. Thank you.